So you're sitting there, waiting for your project to compile. Again, and you have to wonder, has the standard TypeScript and Node.js stack gotten just a little too bloated? I mean, we all absolutely love the type safety, right? But universally, developers are feeling the same pain points. We're talking agonizingly slow build times, massive project directories, and this constant mental overhead of manual error handling just to keep an application from failing silently. So it begs the question, is modern TypeScript simply too heavy for its own good?
Just think about all the baggage required to get even a basic project off the ground these days. You start with npm install. Then, obviously, you need your @types to keep the compiler happy. After that, you're tweaking your ts-config.json, crossing your fingers that you got the strictness flags just right. And of course, this all inevitably leads to the dreaded node modules folder. You know, the punchline of 1,000 developer jokes, famous for being the heaviest object in the universe. We've just kind of accepted this overhead as normal. But what if it actually doesn't have to be?
Okay, let's really dive into this. Welcome to this explainer. Today, we are putting our heavyweight champion, the traditional TypeScript and Node stack, into the ring against a fascinating, super lightweight alternative called Chuks. We're going to look directly at the code, compare the two paradigms side by side, and see if shedding all this baggage might just be the future of how we write code every day.
Here is our roadmap for today's analysis. We'll unpack the TypeScript baggage, meet the Chuks runtime, and then go 3 rounds: setup and tooling, promises versus tasks, and rethinking concurrency. Finally, we'll wrap up by exploring the native binary future.
Section 1. The TypeScript baggage. Let's look closely at the established standard and the friction it causes.
Take a look at this. It's your standard Express.js boilerplate in TypeScript. Just to return a simple JSON response that says status OK, look at all the hoops we have to jump through. We import Express, we import request and response types, we instantiate the app, set up the route, and finally listen on port 3000. Under the hood, this requires pulling in huge, heavy external dependencies. The code itself isn't terrible, but the sheer weight of the environment you need just to execute these few lines is honestly pretty wild.
Now here we have some basic TypeScript variables and console logging. We define a string for the username and number for the user age, and we log them out. Look, we all agree that TypeScript gives us fantastic safety. Knowing for a fact that user age is a number, that prevents countless runtime bugs. But the execution environment itself still carries all that weight. You write this clean code, but you still have to transpile it, manage the module's resolution, and run the whole shebang through Node.
Section 2. Meet the Chuks runtime. This is a lightweight solution built from the ground up to solve that exact bloat.
The real game changer here is how Chuks approaches execution. For dev work, you just use Chuks run. It runs instantly via a VM in a REPL style. There is literally no compilation step blocking you. But the real magic is the second command, Chuks build. This takes your project and compiles it directly into a zero-dependency native binary. So when it's time for production, you just execute that binary file. No Node runtime installation needed on your server, and absolutely no Node modules folder to deploy. It completely strips away the dependency bloat.
Round 1. Setup and tooling. Let's compare the actual friction of getting a project started.
Check this out. On one side, this is your standard TypeScript setup. You're running npm install express, then you're running another install for TypeScript and types, then you have to compile the code, and finally, you run it with Node. That's 4 distinct, time-consuming steps just to see your code work. Now look at the other side with Chuks. You write your code, and you type Chuks run. That's it. And when you're done, you build a standalone binary. The contrast in developer friction here is literally night and day.
Round 2. Promises versus tasks. Asynchronous code is the lifeblood of modern apps, so how do they compare?
Real quick, before we look at the code, let's define our terms. In standard JS and TS, we use promises. They're powerful, sure, but they are heavy wrappers around asynchronous states. Chuks introduces this concept of a task. A task is a streamlined, native representation of asynchronous work. By avoiding the heavy abstractions of the JavaScript Promise API, tasks are designed to be leaner and much faster to execute. And this comparison perfectly shows the difference in practice. With the typical TypeScript function fetching a status, it returns a promise. We await the fetch API, but then, and we've all done this, we have to do a secondary await with response.text just to get the data out of the generic response wrapper. With Chuks, the function returns a task. We simply call http.get, and we can immediately return response.body. It's a subtle simplification, sure, but it completely removes the boilerplate of unwrapping web API responses. It just goes straight to the point.
Round 3. Rethinking concurrency. If you write web servers, you know executing tasks in parallel can be a total headache.
Oh man, if you've written code like this, you will definitely feel a familiar pain. To fetch a user and their orders concurrently, we use promise.all. But notice that giant try-catch block we have to wrap around it? We have to do this because promise.all fails fast. If fetching the user succeeds but the orders fail, the whole thing throws an error. Without really careful manual handling, you end up with silent failures or memory leaks. It's messy, and honestly, it just obscures the actual business logic of what you're trying to build.
So let's compare that directly. You've got the messy array destructuring and forced try-catch blocks of TypeScript on one side. On the other, look at how Chuks handles this with the spawn keyword. We literally just say var user task equals await spawn fetch user. We do the exact same for the orders. The spawn keyword elegantly assigns individual asynchronous tasks to variables. No callback hell, no all or nothing risk. It just reads cleanly top to bottom.
And building on that, look what happens next. After you spawn those tasks, you simply await the variables independently when you actually need the data. You just type var user equals await user task. The tasks are running concurrently in the background, but your code remains perfectly synchronous in its readability. This is a huge win for code comprehension, and it totally removes the mental load of tracking complex promise arrays.
Section 6, the native binary future. Let's look at the big picture of what this means for developers.
So let's tally up the scorecard across our 3 rounds. For tooling, TypeScript gives us a heavy, multi-step pipeline, while Chuks offers zero-dependency, instant execution. For async, we move from the heavy wrapper of promises to native, streamlined tasks. And for execution, we transition from relying on just-in-time compilation and a bulky node environment straight to a standalone native binary. When you put it all together, the sheer weight difference between these two is massive.
The big takeaway here is actually pretty simple. Dropping the baggage absolutely improves your quality of life as a developer. When we strip away heavy tool chains, constantly updating dependency trees, and complex async abstractions, we get our time back. We can stop configuring our environments and just get back to what we actually want to be doing, writing great code.
So I want to leave you with this question. As tools like Chuks prove that we can actually have type safety, elegant concurrency, and native execution all bundled into one tight package, will standalone compiled binaries eventually render the node modules folder completely obsolete? It's entirely possible that the future of web development is much, much lighter than its past. Keep exploring, keep questioning your tech stack, and we'll see you in the next explainer.